Welcome back. As promised, I did say that in this part of the video we are now going to be exploring what goes into sketching of functions. Now, as you may recall, that I did say that the standard form with the straight line function takes this form of y is equals to mx plus c. And at the very beginning of this video series, when introducing linear functions or introducing functions, I dared to mention that the most and single central point that you are going to be using with every form of function that you're going to be dealing with is always and forever notate the standard form with regards to the specific function you are dealing with. So it's important for us to be able to see that y is equals to mx plus c, no matter a pile of tricks that the examiner is going to be using on us. There's going to be scenarios that we will be discussing as we are doing past paper questions as we go further along in this series, where examiners use a pile of tricks to trick you or to try and hide this y is equals to mx plus c for you. Hence, I'm stressing it upon you this very early on to say always and forever try and see that standard form, right? So let's suppose you're given a simple instruction: draw a neat sketch of f of x is equals to 2x minus 6, right? So this then means, since what we've noticed that the standard form we are given here is of a straight line graph, we need to remember a few things as it specifically pertains to a straight line function. Amongst others, we ought to remember the standard form of a linear function, that y is equals to mx plus c, and we also ought to remember that this m in y is equals to mx plus c represents the gradient, which is the determining factor for our shape of our graph. If this gradient is positive, our graph should be increasing from left to right. If this gradient is negative, our graph should be decreasing from left to right. So it's also of paramount importance for us to know that in this particular case, we are not going to be calculating the gradient when sketching. However, we are rather going to be the ones that are tasked with sketching the graph. We are given the gradient now in here. According to this format in here, it says f of x is equals to 2x minus 6, with the 2 being our m. Now note there that this is a positive 2. This positive 2 then means our gradient is positive, meaning we are expecting a sketch of a graph that is increasing from left to right. That's just us building a narrative before we start doing the things. And then there's also the part of the C. Now, with regards to the C, I need to remind you something very important that I introduced very early on. I said to you that this C in here, this constant of ours, is denoted, or it denotes the point where the graph cuts the y-axis. It denotes the point where the graph cuts the y-axis, always and forever. So C is always the point where our graph cuts the y-axis in every straight line graph. That is always the case. Clear enough? Hopefully that is. So what then do we do when sketching functions? These are the steps that we are gonna be following. When we are sketching straight line functions, our first step is always gonna be, for always and forever, to calculate the x and the y intercepts. After we've determined our x and y intercepts, we are gonna plot now those x and y intercept points on our graph. And then after plotting those points, we are going to draw a straight line connecting the 2 points, thus drawing our graph. So it's only three steps. So let us now, you and I, get into the first step of calculating or sketching the graph, which is to calculate the x and y intercepts of the graph. So when calculating the x and y intercepts, it's very, very important for us to remember that at the x-axis, anywhere along the x-axis, this in here is our x-axis, that right there is our y-axis, with it being continuous as we know the graphs to be. Now anywhere along the x-axis, y is equals to 0. So in order for us to find our x-intercept, we then have to make y equivalent to 0. So in this equation here, we are going to make y equals to 0. So f of x, that's our y, we're going to say 0 in the place of f of x, in the place of y in other respects, we are just going to place a 0. Y is equals to mx plus c, which is 2x minus 6. Note, if you will, for those of you that didn't pick it up, that I said 0 is equals to 2x minus 6, which is the same as what we have in here, except in the place of f of x, I just replaced it with 0, seeing as along the x-axis, y, anywhere along the x-axis, y is equals to 0. So I substituted 0 for the position of y. And then what do I do next? Next, I take the 6 or the 2x to the other side. So the 2x skips the equal sign, it goes from positive 2x to negative 2x is equals to negative 6. What do I do next? Divide both sides by what? The coefficient of x. The coefficient of x, which is negative 2. So negative 2 divided by negative 2 is going to give us 1x, which is equals to negative 6 divided by negative 2. It gives us a 3. Then we now have our x-intercept at where x is equals to 3. Then next, we have to determine our y-intercept. Now, if you remember that our c in here represents our y-intercept. Now, meaning from this given graph in here, or the given equation in here, I already know what my y-intercept is going to be. It's going to be negative 6, seeing as my c is negative 6. But I'm going to go ahead with an assumption that you or I have forgotten that this c represents where the graph cuts the y-axis. How was I then going to approach it if I had forgotten that the c represents where the graph cuts the y-axis? So first off, we ought to remember that anywhere along the y-axis, x is always equals to 0. So hence, in order for us to determine our y-intercept, we always and forever make x equals to 0. Then in the next step, we take our graph to say f of x is equals to 2, but in the place of x, we are going to replace it with what? 0. We are substituting 0 in the place of x minus 6. For those of you that haven't picked it up yet, this first line f of x is equals to 2x minus 6 is the same as this f of x is equals to 2x minus 6. The only difference is in the position of x, I substituted 0. Why? Because along the y-axis, x is always 0. Now in the next step, we just say, or we remember that f of x is the same as y. So I can just reduce the f of x to a y. This f of x I change it to a y to say 2 times 0, that's 0 minus 6. So y is equals to minus 6. So at this point, what do I have? I've got my y-intercept, I've got my x-intercept. So according to the steps that go into sketching a function, the first step is to calculate the x and y-intercept. I've already done that. The next step is to plot the points. So let's go ahead and do that together. So here's us plotting the points now. X is at what? 3 and positive 3, and y is at minus 6. So let us suppose that the point minus 6 is somewhere in here, y is minus 6 somewhere in there, and x is positive 3 somewhere in here. That's us now. We have plotted our points. The next step in sketching, for sketching a straight line graph, is what? Draw the freaking graph. So we are gonna draw the graph. when we draw the graph, we are doing nothing complicated, to be honest. We are just going with the flow. We are just gonna take a straight our ruler from one point to the next and plot a straight line between the 2 points. That straight line would then represent our graph. So this straight line that I've just plotted here for you, this is our f of what? This is our f of x. That's all that goes into sketching a function. Now, by all means, please do check out the description below. There should be a link to an exercise that you can take right about now to actually test yourself as you've grasped the concepts or the main core of sketching functions. If you do check out the exercises in the link and you still find it a little bit difficult, I'll be sure to leave another example in the next video where it is just the same thing, where I'll be sketching the same type of function with just a slightly different example. Now in the next example, I will be sure to give you an example with a negative gradient. Thank you very much.